access to that via a gRPC API if you're interested in doing something a little more fancy with that data. So really excited to put that out there, get people looking at it. There's a bunch of other cool related features, like the ability to stage policies and see their impact through this flow data. So I encourage everybody to go check it out, raise issues if you hit anything, talk to us in Slack if you have feedback or suggestions, and let us know what you think. We can throw, Reza, do you have the meeting notes up by chance? If you just throw a link to the release notes on the web page in the notes, that would be great.
100% just as
I think the next thing is we're trying to stick to our patch release per month. So we have a 3.29.4 coming up, which will mostly be just like Golang and CVE updates. There are a few small bug fixes as well included in that. The ones that I'd call out most explicitly are related to tier naming. So I think these haven't actually been merged yet, but we're hoping to get them into this patch. In 3.29, we introduced the concept of policy tiers, and as part of that, we introduced a bug where the name of policies change on upgrade, which is obviously problematic, especially for users that have GitOps, CI/CD type pipelines managing their resources. So we have a couple picks in process to handle that and fix that naming change. So those will be hopefully in 3.29.4 and then definitely in 3.30.1, which doesn't have a date yet, but is in the early stages of formulation. Don't think I have a lot to say on 3.31 because we just got 3.30, so we'll figure that one out.
Do you know approximately what's the tentative schedule for it? Is it usual 3 months or 6? I don't recall the frequency.
Best to answer that one. Given you.
Probably 6 months.
Okay.
I don't, so I kind of October maybe.
Okay, so end of year essentially.
I don't know that that's. I wouldn't say it's set in stone necessarily, like, especially with all of the new kind of features. Like if we realize soon that there's something we would really want to change that needs a minor bump, we could potentially do that. But
no, sure. I'm not searching for something like quite aware of. Yeah, release process always go that way, but just to get a sense of what you're targeting, because I know sometimes you, depending on feature, you say we're trying to do a closer one. So just
we're trying to make it consistent, but we'll see.
Thanks.
Cool. I think that's all I have in terms of release updates. Pretty quick because we just got 3.30. Reza, did you have a plan for Dimitri to go next?
Yeah, so if we can, I believe he's in. Hello, Dimitri. Can you hear us?
Hello, yes. Also, I invited Mohammed, who is another admin in our cluster, and he will talk about the cool experiments, network experiments he's doing, and I will cover the general information about the cluster.
Hi all, hope everyone is doing well.
Okay, start presenting.
Looks like we've got a camera too.
Community meeting, yeah.
see, how do
All right. Oops. All right. So hopefully everyone can see us and go.
Okay, am I sharing? Okay. So I will talk about the National Research Platform and Nautilus Kubernetes cluster. National Research Platform covers currently 70 institutions, mostly in US and some abroad. The head node is in UC San Diego Supercomputer Center, and also parts of the team are in University of Nebraska-Lincoln, and there is a big part in MGHPCC, Massachusetts data center. Cluster is built out of hardware, mostly sponsored by National Science Foundation. Some nodes are DOE, DOD, and some other funds and organizations in US. So mostly NRP operates a Kubernetes cluster. As I said, so we have some nodes abroad, and we are covering 3 continents. Okay, so this is the map of the nodes. Again, this is a single Kubernetes cluster, mostly in US, some nodes in Europe, and some nodes in Pacific region, South Korea, Guam, and Hawaii. And on the bottom, there is a link. You can see this map. There are multiple things that we do with Kubernetes besides just providing compute, and one of them is providing storage for OSG mostly. And the idea for that was to draw these big circles in US. I think it's some number of miles or something, but there are 3 main centers, UCSD, University of Nebraska-Lincoln, and Massachusetts. It's called Origins, so they store large amounts of data. And then there are so-called stash caches, mostly on Internet 2 backbones, and those are caching data from Origins and providing to clients. And the idea is that every client in US is covered by one of the storages in like close to them, and requests are automatically go into the closest one. So we've been operational for 6 years. Currently, there are more than 400 nodes, more than 1,400 GPUs, more than 50 FPGAs, Bluefield 2 smart NICs, smart SSDs, Tafina switches. We provide a lot of storage. It's close to 10 petabytes now of Ceph storage. Also CVMFS, which I was talking about already. S3 as a part of Ceph. For monitoring, we use Perfsonar. It's a ESNet tool for active network measurements. Also SFlow and several collectors for SFlow, including Inmon, Traffic Sentinel. And of course, Prometheus is grabbing a lot of different metrics from various parts of the cluster. We provide a lot of compute, and on top of that, there are additional services like Jupyter Hubs. Currently, we have around 50 or 60 different Jupyter Hubs deployed in the cluster. WebODM for processing drone data, GitLab for storing, just providing Git and CI/CD pipelines, Nextcloud for data sharing, Overleaf for publications, editing, and so on. So these are all services that we support as cluster admins, but also users are free to deploy their own services in the cluster. Collaboration and communication, Jitsi, that's for video conferencing, Etherpad, HedgeDoc, that's for collaborative editing of data, SyncThing for, again, data sharing. again, we have 1400 GPUs in the cluster, from 4 to 8 GPUs per node. Nodes typically have like 550 gigabytes of RAM, but nodes are very different, like from 30 gig to more than terabyte of RAM. A lot of types of GPUs. A100s are the biggest and fastest, but we have a lot of older ones too. So users can pick what they need for their workload. Also now we're playing with Qualcomm accelerators, which are cheaper than GPU. So we are hoping that we will run LLM on those very soon. And for storage, Ceph, LeanStore, S3 as part of Ceph, and OSG, those stash caches and origins. And of course, we use Calico. So all nodes have Calico installed as the main CNI plugin. Provides overlay network for Kubernetes. Nodes have 10 to 400 gig connectivity to Science DMZ, so that's the dedicated scientific network. We require no firewalls on between the nodes and Jumbo frames. So most nodes, except like 2 or 3, probably have Jumbo frames between all nodes. And every node also has connectivity to internet to pull images, or users can pull their data, push their data, whatever they need to do. Usually it's slower than Science DMZ, but we still require every node to have connectivity to commodity internet. Calico is running as just daemon sets. We are not using operator, and the reason for that is that nodes are very different, and currently we run 3 different daemon sets. One is for IPv4 only nodes. Another daemon set is for dual stack, IPv4 and IPv6 nodes. And third daemon set for those couple nodes that cannot have Jumbo frames, but we still want to have them in the cluster. Calico provides network policies on the nodes, so nodes don't, like, we require that university doesn't put their firewall in front of the node because it kills the performance, and we just can't manage firewall flexibly by dealing with every university because we have too many. But we use Calico network policies to put cluster-wide network policies everywhere. So we open just a few ports to the world. All ports between the nodes are open, and based on node labels, we can also open certain services to the world, like those stash caches or Jitsi video conferencing or stuff like that. So we can still open certain ports that we need ourselves. And also Calico provides the workload level network policies. So if we want to protect something inside the cluster, so we also use Calico for that.
I'm sorry, I was curious about just from a perspective of, obviously like to make it possible for people to use the operator as an installation mechanism. I just wanted to check whether the only limitation you had that prevented you from using it is this ability to have basically separately configured Calico node daemon sets for different types of nodes.
Yeah, I don't think operator supports it now, but if it does, then we will be definitely interested in using that. And for that, we would also need, because we started using Calico way before you guys developed the operator. And I'm not sure if there is a way to transition from regular to operator, like without disrupting the cluster operations. So
yeah, there is an automated migration, but we need to make sure that the operator is capable of providing all of the features you need. So it sounds like the big gap is most likely this distinct node group concept running different daemon sets or configuration.
Right, yeah.
Cool. Thanks. Sorry for the interruption. Please
Yeah,
go ahead.
that's a great question. Okay, so now I will pass it to Mohammed, and he will talk about all the network experiments we're doing.
Hi everyone. Just to quickly discuss on our network experiments that we conduct on the cluster, because essentially it's an academic cluster mainly used for research and education. I'm just going to show you a few brief examples of how we use the cluster for those sort of experiments. I'm just going to share my screen. I hope everyone can see my PowerPoint.
Yep, looks good.
And sorry, slideshow. Share can, hopefully everyone can still see it.
Yep.
All right, so we use a service called ESNet Sense for path provisioning for L2 and L3 paths. And Sense was developed by the Energy Sciences Network at the Department of Energy, so ESNet. And it was mostly developed and hosted on the NRP Nautilus cluster. So it runs on the cluster, it constructs a topology between many of our nodes and multiple other sites like the Fabric testbed, many hosts and servers on the Internet 2 backbone and the ESNet backbone. And we use their orchestrator to establish paths between the nodes. And essentially, we use it two ways. So we can attach the main interface and can attach secondary interfaces. So for attaching secondary interfaces, we're using Multus, the Multus container network plugin, interface plugin. And essentially what the orchestrator does is that it is installed on the Kubernetes nodes as a service using something called their site resource manager. And it does all the configurations on different kinds of switches to the point where the user is agnostic of all of those things. The side RM tools are sort of agnostic of the switch kind, switch OS, so on and so forth. It just allows to establish those paths, and once the path is created through a set VLAN, it establishes quality of service, and then it starts that VLAN as a sub interface on a MAC VLAN interface on the node itself, and then we provision that interface to pods using Multus. And the developers of ESNet, the Sense, are active users of the cluster themselves, and they've been pushing for Calico VPP from day one because it allows them to do much more stuff that they're per their description allows them to do much more stuff than they can use Sense for. Mainly with using the primary interface. So the paths are not set through the Kubernetes overlay, but they can set the explicit paths through their orchestrator and offload parts of the processing logic. I offload from IP tables to VPP to user space, bypass the kernel. It should achieve higher and higher performance if I understand their description right of the problem. But in terms of our use, once we have the secondary interface, we attach it with Multus, and then we can start up pods. And this is not only something that we use for ourselves as the operators slash researchers, but we offer it to the research community where users can have 100 gig per second guaranteed quality of service between two pods where they can carry network experiments, they can carry AI experiments that rely heavily on moving data, and they can carry inner testbed experiments with the federated testbeds like the Fabric testbed, Chameleon Cloud, and these other NSF-funded testbeds. And these are all part of what we call the AutoGoal or Sense topology, which is these networks that I'm talking about. So this is on the bottom right, this is the same map that Dima shared. The blue pins is sites where the National Research Platform has nodes. We're limiting it all to the United States. Left to it, you can see these are Fabric testbed sites, and we can virtually connect to any of these using the orchestrator. And at the top, you can see the ESNet topology and the Internet 2 topology. And using the orchestrator, we have a master topology that we can connect all to all of them as well. And just a little bit about Sense. It's short for software-defined network, end-to-end network for science at access scale. And we as Sense users, we can see the paths, the VLANs, we have a high level of autonomy in what we're provisioning. And as well, we provide it to the users through an operator. So users can set paths between nodes that they can establish either through the pod definition in their YAML. So users can say, I want this pod that I'm establishing to connect to another pod at a different node, or they can set an object that we call sense path or a custom resource that they define the two nodes and the secondary interface that they're using and the quality of service bandwidth they're trying to request. And if possible, they select an explicit VLAN rather than being assigned one automatically. And this is just an explanation of how the pipeline goes. So users start the sense path, which is the custom resource that does everything under the hood. So start the L2 path, add the network attachment definition in their namespace for Multus, and allow their pods, once they start their pods, allow their pods to use the path through annotations. So through labeling labelings in their pods YAML, they can use that path. And that's one example where we can use Calico if we implement Calico VPP, and we're the developers of Sense at that point. They're sort of like honorary operators of the cluster because we're in direct engagement with them on a weekly basis in multiple meetings. So they're, as well as us, they're also interested in more and more Calico features, especially with the VPP data plane. And basically, this is the same resources that Dima talked about. So in terms of networking resources, plenty of our nodes have ConnectX 6 network interface cards. All of them have primary and secondary interfaces that can be used for those experiments. We have P4 programmable FPGAs, and we have the U55Cs and the SN1000s, which are the same thing as the U45N, but the U45N was a rebrand. And we have 7 NVIDIA Bluefield 2 DPUs that we're also experimenting with P4 on these ones. So and next to all the Calico features, they can have NVIDIA is also promising P4 on these cards. So it'll be interesting to see where that leads. But we have conducted multiple P4 experiments, like I said, and integrating with other environments. So we use the Fabric testbed. They also have similar FPGAs. They have the U280s, which are also capable of doing P4. Those FPGAs are dual port, 100 gig per second port FPGAs, so they're capable of doing 200 gigabit per second to the network, and they're PCI Gen 3 and Gen 4 cards, so they're capable of sending traffic to the hosts as well. And they can do DPDK applications, and theoretically they might be able to support VPP, even though there might be some engineering there. But we've used them in our P4/DPDK applications for all kinds of real-time, high precision per packet telemetry and for segment routing. And that is all enabled using a toolkit called the ESNet SmartNIC, which is basically a very large number of tools and wrappers around the AMD OpenNIC shell project that allows these cards to be programmed. So the ESNet SmartNIC project has all sorts of tools, command line interfaces, counter probes, all of those things that allow us to interact with it as sort of a small switch on the edge. It's past the point of it being a SmartNIC, and it's more like a smart switch that is fully P4 programmable with an edge over Tofino switches, because we can process entire packets. There is no theoretical cutoff limit for number of bytes. The entire packet goes in. And we've used that for segment routing and having the control plane specify how the traffic is implemented. We've implemented per packet telemetry with segment routing by modifying the packet headers to include timestamps at every hop and or every segment. And the cards are capable of doing timestamping to the order of nanoseconds. So we're heavily invested in doing telemetry on these cards by taking the packet headers, stripping off the payload, and from there we can do all kinds of telemetry works. The thing we're interested in mostly is replicating the ESNet high touch model, which from there you take the packet headers, you encapsulate them in routing headers to send them to database workers that can process the data and store it. And that's one of the experiments that we try to show and demonstrate at venues and show as a reproducible example that is completely open source for the research community as well to sort of reproduce. Here you can see the sort of packet header logic where we strip off the payload and take the original packet, just append it to wherever we're sending the data. And this is where segment routing is doing the work. So we're just encapsulating the original packet with the segment routing headers and explicitly specifying through the control plane how the data is getting traversed. And this way we can offload packet processing to separate stages as the data is being traversed at near a line rate of 100 gigabit per second per port. And we do that across the National Research Platform and the Nautilus cluster to the Fabric testbed. And we use that in conferences as well because the Fabric testbed has a Sienna site that is a mobile server on wheels that Sienna takes across conferences throughout the year, and we incorporated in our research as well, almost as if it's part of the cluster as well. And this is a similar experiment that's segment routing without telemetry that we've also done. And this is sort of an irrelevant topic, but we also provide them in our official documentation as reproducible examples. And yeah, I'm just going to stop here. This was sort of just a brief set of examples on the network experiments that we run on the cluster.
Awesome. Thank you for sharing that. It's pretty cool to see all the different ways that Calico shows up and gets used, and you guys obviously have a very involved setup with a lot of other technologies too. So, any questions or comments?
Just really interesting presentation. Thanks a lot for walking us through that. That sounds really nice. And I'm sorry because I really need to drop because I'm already 7 minutes left to my other meeting. So, but yeah, if you just saying that if you have any feedback or constraints that you had with using Calico eBPF, I'm happy to chat about that as well. So also, if there is a recording of the presentation, I'd be interested just to share with the team as well, because I might be interested as well. So, or just the slides.
Yeah, if the slides are public, please do share, and we'll throw them in the meeting notes so that they can be stored for posterity.
Okay, sure. I'll share the slides, and yeah, let's follow up on the VPP and maybe start the email thread and see.
Oh, on Slack there is a room as well, or we can create a dedicated room as works best.
All right, thank you.
I have to bye everyone. Sorry about that. Thanks a lot.
So, Dimitri, I sort of heard you guys are using SFlow, Inmon, Persona.
Yes, right? If we have time, I can demo how it looks.
May I interest you in an easier way to get those data out?
Sure, yeah, that would be perfect. And yeah, of course, we will test your new release. And my first, so as I understand, it's passive monitoring, not active like Persona. So it doesn't actively measure the throughput. Is that correct?
Wait a second.
Say more about passive versus active in your.
So we have 2 ways. Inmon and SFlow just get statistics from network interfaces and show what's happening there. And that's where I think we can definitely replace it with your new monitoring tools. And the second way to find network issues is to actively sending some data and measuring like the packet log and stuff like that. And that's what Persona is currently doing. So it's sending first it's establishing very low flow TCP connections and sending like a packet every now and then, and measuring how many were dropped. And then it's measuring one-way latency, and then it's measuring throughput by sending like 10 gig of data a couple times a day between every node in the cluster.
Yeah, this definitely falls more in the passive monitoring. It's not generating any traffic itself.
Yeah, we're really excited, and I think it's great. Does it find so now I think our biggest problem is first when some university drops their MTU, and that's really hard to find because mostly they are above 9,000. So we have Calico set at what 8,000. I think it's like 30 something below 9,000. But some universities have it just 10 bytes less, and that completely breaks the tunnel.
Yeah.
And also sometimes they switch to reserve path if their science DMZ breaks, and then they switch to 1500. And detecting that is
that's interesting. It's not something that's in this version of monitoring, but
yeah, that's just giving you ideas of what can be useful.
Yeah, I'm definitely interested in hearing what sort of things are useful for you guys to be able to detect.
Yeah, and second, just sometimes we have some weird issues. Sometimes it's caused by MTU, but also can be like they prohibit, I don't know, UDP and allow TCP or something like that. And so some portion of data is not going through. And I'm hoping that will be detected by your new tool. But as I said, we still didn't get to it yet. So yeah, it's on the way.
Cool. Why don't we let Reza take it away?
So the idea is this is a workshop. Everybody can use it. It's live now. If you go to tigera.io tutorials and click here on basic. As part of the stuff that are in here, there is one at the end, a hands-on guide to Kubernetes observability and policy troubleshooting. So that's one way. I'll put the link, direct link into the community document, and I'll post it for the live folks who are watching us on other platforms. Anyway, so the idea is I got a cluster, it's running Calico 3.30, and I got an application and I want to secure this. Now, I can see all the stuff that are working here. If I click on my wonderful application, it tries to send some packets to different places, such as GitHub, those sort of things, tries to fetch 888 DNS, those sort of things. Now, one of the things that is usually not a good security posture is that everything in Kubernetes can talk to everything else. Hence, my pod here having internet, because at the moment, it's now permitted to talk to everything. And there is a NAT outgoing allowing my pods to communicate to internet. Now, in order to fix the security flaw, what I can do is I can either disable NAT outgoing, which is not the best way, it's just like turn off the host, or I can implement some policies. Now, I do have a policy, and that policy would try to write some stuff. I have now my policy will try to Wait,
Does it have a syntax error?
there is a syntax. Did we change something? Wait, I can fix this issue. So the idea is I'm gonna write a policy. My policy is a global network policy. And it will be in the admin network policy tier. So as you know, with Kubernetes 1.31, there is a new tier called admin network policy, which allows you to write policies in a different tier other than default. Now, I also want to make sure my policy is only applicable to some namespaces. So here are my namespaces: Calico system, Cube public, Cube system, and Tigera operator. And there is some sort of and I want this policy to be both applying to ingress and egress. For my egress, I want all the UDP communications be allowed if it is communicating to a destination called KTAP kubedns. If you go look at it, this is the kubedns pods that we are running. So I want it both on UDP and TCP, because from time to time, DNS talks TCP to communicate to other DNS servers, and it usually talks UDP to communicate and query DNS requests. Now, there is some sort of problem here, which we're gonna fix it right now.
I've been looking for it, I don't see it.
So what we can do is right, there is a Stydian malform. This thing is very.
Oh, I know what it is.
Negative.
Go back. You need to add, the name needs to be admin network policy dot deny.
Oh, all right. All right, that's why you don't just change the release, you also check the release notes. Yeah, thank you. All right, so when you implement your policy, what happens is, well, your application will try to do some do some traffic or send some traffic. Now that traffic will be shown in Whisker in the UI, and you can see what are the places that your application is trying to talk to. You can click on each of these policies and figure out what's going on. You can also go in and figure out if the policy that you wrote is actually being enforced on that pod or that tier or whatever that you have you are trying to target. Now that being said, here there is, I have to go figure out why this is not working with the 3.30. So there's an update. Anyway, the whole idea is when you run your policies and run your Whisker, it will show you all the information that you would need to troubleshoot these sort of information. Now, that being said, there's also another workshop, which is on Tigera IO blogs, that one is about Goldmane. So all the stuff that you've seen on Whisker listening there, it's coming from a component called Goldmane. And if you come to this blog, somewhere around here, it gives you access to another workshop, which is about Goldmane. In that workshop, you will learn how to communicate with Goldmane, take stuff out of Goldmane without using Whisker. So if you want to build something like Dimitri, that would be the place to look. And with that, I'm going to stop the demo.
Thanks, Reza. Sorry that the demo gods are always working against us.
Yeah.
But that's just the way it is. Something for us to investigate.
It's my own fault because in the morning, I changed the release tag from whatever I was using to 3.30 something. I'm like, okay, I know I don't have to check it. You know, you always have to check. That's why you should read the release notes. Okay.
Great. Any questions, thoughts? Oh. All right. In that case, we're pretty close to the end of time. So just want to say thanks, Dimitri, Mohammed, for joining us and sharing that with us. It was great to have you guys. Thanks to everybody who popped in on the stream and other platforms as well. And we'll see you all next month.
Thank you.
Thank you.